All right, we have lesson 3.1.1, spatial visualization and reflections. So what we're going to look at is how can we, in our mind, move shapes around without actually having to move them on the paper. And then we're going to start looking at different types of transformations. All right, so we're going to start off with what are called nets. And here we're going to build boxes. Let's pretend that on these boxes, we want to see which one is going to actually have a lid on it. So you can pick anything to be the bottom of the box. I'm going to pick this one right here to be the bottom of the box. Okay, so we want to see of these four, which ones is actually going to give us a box with a lid. So we have to pretend like these are the folds on the box here. So if we started folding these, which one would give us a box on the lid? A box with a lid. So this first one, okay, so I would say, okay, this is the bottom, so I'm going to fold this one up, and this one would be going up and down here. This one I would fold, so going up and down here, so I've got two sides to the box so far. This one would fold over here, but this part would fold with it. So if this one is being flipped up to here, then what we can see is this other section is going to flip over to here. So this is going to be up, and then this one would actually be this portion of the box here, but we would get no lid. So this one would give us no lid. The next one, you can pick any one of these to be the bottom of your box. I'm going to pick this one. So this is the bottom of my box. Okay, so if this section is tilted up, and then this part is tilted, so this section gets moved up and this part gets tilted, now we have two sides to the box. So this becomes this upward section here, and this one, if we tilt it in, would become this upward section. Over here, this one would be tilted up. This one, if we fold again, becomes the top of the box, and then this one goes over here and becomes the bottom of the box, or the front of the box over here. So this one gives a lid. So B works. Look through C and D and see if you can figure out which ones of those are going to give you a box with a lid. I'll go ahead and pause in 3, 2, 1. All right, we see here that like this one here, if this were the bottom of the box, this portion would be the standing up portion over here on the top, and then folding in this one, that would be the standing up portion right here. And then on this side, this one would be the standing up portion here, and then we'd flip this part in and it'd be the standing up portion, but no lid on this one. For this one, probably the easiest of them all, this becomes a side, this becomes a side, this comes up and becomes a side, this one comes up to the side, and then this one becomes the top of the box. So this is the top right here, and these are the four sides of the box. So this one gives us a lid. All right, so I don't know if you've ever seen this before, but a lot of ambulances, the front of the ambulance looks like this. The word ambulance is written backwards. Anybody see that before, or do you realize why they do that? The reason why they do that is if the ambulance is driving behind you, you're usually going to look up into your rear view mirror and see it behind you. And if you see this in a mirror, you're going to actually see the word ambulance written correctly. So this is a reflection of the word ambulance. In a mirror, it looks like it's written correctly. So what we're going to do is we're going to look at all of these words and try to write how they would look like in a mirror. Okay, so let's pretend like the mirror is right here. And I want to see what Geo would look like in the mirror. Well, in a mirror, the closest thing to the mirror shows up on the other side. So O is the closest thing, so O would show up here on this side. Now E would have to face that way. So there's E, and then the G would also have to face the other way. This is kind of hard to do. Close enough. Oh, I did it wrong. Okay, good enough. All right, so there's geo backwards. All right, do the same thing for star and the same thing for wow. All right, I'll pause in 3, 2, 1. So as we're going through this, we notice that some letters show up the same backwards or forwards. T and A are both letters that show up backwards and forwards. We saw earlier the O was a letter that looks the same backwards and forwards. So when we got down to wow, W's and O's look the same backwards and forwards. And so wow looks like wow when it's in the mirror. So it's the same exact thing. All right, let's move on to problem 3-3. All right, so this is a visualization problem. So we've got a flag. So this kid Kenji, he's got this pole, and then there's a flag on top of the pole. What Kenji is going to do is he's going to spin this pole really quick. So the flag is going to move around and around the pole. And when he spins that really quick, it's kind of like when you shake a pencil or something like that. It looks like it's in several places at once. That's what this is going to look like. So he's spinning this flag, and he notices a three-dimensional shape that the flag is making. So if he spins that, what would that flag look like? Draw a picture of what you think he would see. So if you could pause here if you want to. But here's what he would have seen. He would have seen, okay, here's the flag. Well, spinning around, it would have looked like a cone. So there's the pole right there. Spinning it around would have made it look like there's a cone there. So you probably would have seen a cone. All right. So it looks like a three-dimensional figure when he's spinning this around. Second question, what would the flag need to look like so that it looked like a sphere were being made? Okay, so draw a picture of what you think it would look like if that flag, what shape would the flag need to be if when he started spinning it, we needed a sphere? So you can pause it now if you like. Here's my answer. So we've got our flag here. If we want a sphere, we would need a semicircle here. And then when you spin it around, well, I'm really bad at drawing this morning. Sorry. When you spin it around, it'd end up looking like a sphere there. All right, so Hunter decides, hey, I'm not going to spin it. I don't have time for that. I'm going to only turn it 180 degrees. So if he turns that pole 180 degrees, which way would the flag be pointing? I think most of you would know. Instead of pointing this way, the flag would be pointing the other way instead. So it would be pointing towards the left instead of pointing towards the right. And here's what we get is what's called a reflection when we do that. It's pointing this way, now it's pointing that way. All right, so we get to reflections. You're going to want to use your resource page at this point because we're going to work off of those at this point. So if you got this resource page here, we're going to kind of practice these reflections. So when we have a reflection, we've got a original. Sometimes we call that the pre-image. We've got a line of reflection. So everything on the original is the same distance to its image. So like this eyeball is the same distance to the line of reflection as that eyeball is. So everything keeps its distance to that line of reflection in the image. And notice how the facing is. If this one is facing towards the line of reflection, this carrot nose here is facing towards the line of reflection. Everything faces towards that line of reflection if it was already facing towards it. If it's facing away from the line of reflection, on the other side it would be facing away. All right, so how is this image different from the original? Well, number one, we can see that this image is facing a different direction. And that's why those letters look so weird on the word ambulance, because all the letters are facing the wrong direction. All right, so now we're going to complete the reflections that are found on the resource page, which is this page here. I'll do the first couple with you, and then you can finish them off, and we'll see how you did. All right, so here is my first shape here. So what I'm going to do is I'm just going to take each kind of corner here and then put it where it should be. So this corner is 2 spaces away from the line of reflection, so it's going to show up 2 spaces away there. This other corner is 3 spaces away. Okay, so there's that top part there. This corner is 1 space away, so it will still remain 1 space away. Okay, this corner down here is 1 space away. This corner is 3 spaces away, so 1, 2, 3 spaces away. And then this corner is 1, 2, 3, so 1, 2, 3 spaces away there. And then it goes boop, 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 and boop, right there. So now we have the shape written as a reflection of its shape. All right, I will also do number 3 with you. Number 3 is a little bit weird because we have a diagonal line, but remember we have to be the same distance to the line of reflection. So when we do that distance needs to be perpendicular to the line. So this corner here ends up being this corner right here. And then this corner is diagonally, see, going diagonally through there, right here. And so we get our first line right here. Okay, so this line here and this line here are both the same distance away from that line of reflection. Okay, so what's really hard about this one is making sure that you are staying perpendicular when you make your new points. So here, this one, you've got to go diagonal as you go. So this is a diagonal of 1, 2, and a half. So half, 1, 2 would go right here. So you're counting diagonals to each of these parts here. Now this one is 1 diagonal, 2 diagonals, and 3 diagonals. So I'm going to go 1, 2, 3 right there. Oh, I missed this one. Did I? Yep, I missed that one. So this is going to be 1, 2, so 1, 2. Okay, and this one's going to be 1, 2, half, half, 1, 2. All right, and I think I've got, what, do I have one more? 1, 2, 1, 2, right there. And there we have a reflection going that way. All right, I will pause. Number 6 is already done for you. That's silly. That must be a mistype. Oh well. You've got to do number 2, 4, and 5 really quick. All right, I'm going to pause. All right, so here we go. So here, this one, my line of reflection was here. So this point, since it's on the line of reflection, it does not move in the reflection. It's only the other 3 points that moved. So they are just the same distance. This one was 2 spaces away. This one was 3 spaces away, so it went 3 spaces here. And this one was 2 spaces away there. This one, we had to go a diagonal, and these 2 points moved over to here, and these 2 points moved over to here. Now notice what we're doing here. Each of these is creating a shape that is the exact same size, just in a different place. So when this one is done, it looks like we fill out the rest of the T. And then I just realized that this one actually wasn't finished, but what happens is when you reflect this side over to here, it's on top of it. And this side gets reflected over here and it's on top of it. So what we have is something called symmetry, where we're splitting it right down the middle and it's the same on either side. So if you split an M down the middle, it's going to be the same on either side. So it's already reflected on top of itself. It's just like the T here, except it wasn't finished on this side. The T, when you split it down the middle, it has symmetry. It's the same on both sides of it. All right, so let's move on to 3-5. And we'll go back to that reflections resource page in a second. All right, so looking at these 4, sometimes your brain plays a few tricks with you and it's hard to see exactly what is a reflection and what's not a reflection. So I've got 4 here that I want you to look at. I want you to decide which of these is a reflection and which of them is not, and then explain why. All right, so I'm going to pause and let you decide, and then we'll see how you did. 3, 2, 1, pause. All right, so here's my answers. The first one is a reflection. We can tell because the mirror images, each section is equidistant from the line of reflection. Equidistance just means the same distance. Number 2 is not a reflection. You can tell, really look at the dark one right there, that dark leaf and that dark leaf. They're not the same distance. They're facing in the wrong way. It's like this one was spun around or rotated instead of being reflected. Number 3 is also not a reflection. If this were a reflection, this face should have been upside down because we're flipping it over that line right there. And the last one is a reflection. I was just checking it out. It looks like we do have the same distance for our corners here. They're the same distance from each other from the line of reflection. All right, last one. We're going to complete the last thing on the resource page, 3-6. So we're going to kind of look and say, how does our observation relate to the equation for the line of reflection? So here's what's going to happen. We're going to start by graphing the vertices of a triangle. So G is at 1, 3. So let's see. Let's do this in pencil in case I screw this up. All right, 1, 3. So there's G. L is at 2, 7. So 2 and 7. So here's G, L. And then M is going to be at 5, 6. So 5 and 6 goes right here. All right, so there's our triangle GLM. Okay, so hopefully you're making your triangle GLM. All right, and now we're going to make the line y equals x, and we already know how to do that. The line y equals x starts at 0 because that's the y-intercept, and then it has a change in y of 1 and a change in x of 1, so it just goes up 1 over 1, up 1 over 1, and so on and so forth. So our line of reflection should be this right here. So there's my line of reflection. All right, so I want to reflect over that line. It looks like M would be right here. And when we do a shape like this that has letters to show that it's the image, we do M prime, and it's like an apostrophe next to it. Is that apostrophe? Yeah, I think so. So M is an apostrophe, so we call that M prime. So there's our point that's an image of M, M prime. L prime, we would go diagonally, so it's a 1, 2, and half, so half, 1, 2. So here's L prime right here. And then G is 1 diagonal away, so I go 1 diagonal away over here. All right, and there is our reflection of the triangle. Okay, so here we've got GLM, and then we have G prime, L prime, M prime. Those are the images. So what they want you to do is really look at the actual coordinates of each of these points and compare them. So look really close, compare the coordinates to each other. I'm going to pause as you kind of look at them. So to help you out, I've written down the coordinates in blue. That's the pre-image, the original one, and then the image is in red. Now look at M and M prime. M is 5, 6, M prime is 6, 5. L is 2, 7, L prime 7, 2. G is 1, 3, G prime's 3, 1. So hopefully you saw the relationship there. What we observed is the image, when we reflect over y equals x, the image has points that have the x and the y switched. So they've been switched with each other. And the reason is because the line is y equals x, which means the x becomes y and the y becomes x. So whenever we reflect it over the line y equals x, what we're going to see is our 2 points change positions. So a 1, 3 becomes a 3, 1. So whatever in the x becomes the y, and whatever is the y becomes the x. And that's all that we have for you today. All right, enjoy yourself, do your homework, be good, tell your parents you love them.